So here we're going to show an example of finding the Miller indices on hexagonal crystals. They're a little bit different than, say, monoclinic or triclinic or cubic. All the other systems have only three axes, maybe an A, B, and C for monoclinic or triclinic. Or if we have a cubic crystal, we have an A1, A2, A3. So there are just three axes in the examples as we've shown in other videos. But for hexagonal crystals, we have a little bit different of an arrangement. We have a vertical C-axis, but then we have an A1 coming front to back, and then an A2 left to right, and then an A3 that goes also front to back, but at a different angle. So we've got four axes total instead of three, so that's a little bit different. It makes the hexagonal system a little bit unique for the Miller indices. And here's a very nice figure from Dexter Perkins' online textbook for mineralogy. We're going to use an example of crystal like this, and in particular, we're going to look at faces like this that are parallel to the C-axis, just to simplify things a little bit. So we can consider looking at this face or that face there. We're going to take a face that just is going to cut only the A-axis and not the C. So let's go ahead and clear the chalkboard, and we'll have our C-axes, and then an A1, A2, and A3. And then we'll have a case of a crystal face that is, let's say, moving in this direction here. Let's draw it from the top down as if we were looking down on the C-axis. So if we redraw that, then our axes would have an A2 here, and then an A1 here, and then an A3 here. Now the way these are numbered is that if this is the C-axis in the center, and we are just looking straight down along the C-axis, so here's the C-axis here, then this would be the positive end of the A1, positive A2, and positive A3. So that would make this negative A2 over here, and negative A3 over here. So let's take the case of a face that looks like this. It's just going to hit the A1 and A3 axes. It's going to be parallel to A2 and also parallel to C. So what would the intercepts be? We would have a 1A1 and then a 0, and an infinity A2, because it's not hitting the A2 axis, it's parallel, and then a minus 1 A3, and then an infinity C. So our intercepts are 1, infinity, minus 1, infinity. So let's erase the chalkboard and give us a little more room. So it's a 1, and then we had an infinity, and then we had a minus 1, and then another infinity for the intercepts of A1, A2, A3, and C. So if we invert these, then we get 1 over 1, 1 over infinity, 1 over minus 1, and then 1 over infinity again. That would give us 1, 0, minus 1, and 0 again. A minus 1 gets a bar over it. So the Miller indices for that particular face that we drew in the previous slide would be 1, 0, bar 1, 0. So those are the Miller indices for an example of a crystal face on a hexagonal crystal.